Welcome to Ask and Learn.
In this question, I want to use polar coordinates to find the limit. And they note that if r comma theta are the polar coordinates of a point xy, where r is greater than or equal to 0, note that r approaches 0 from the right as xy approaches 0, 0. So here I want to find the limit as xy approaches 0, 0 of the quantity of x squared plus y squared times the natural log of the quantity of x squared plus y squared. So what do we do? Well, I know that in polar coordinates, x squared plus y squared is equal to r squared. And so converting to polar, I'm going to have a limit. Now, if xy is approaching 0, 0, they say that r is approaching 0 from the right. Now, my x squared plus y squared, that gets replaced with an r squared. While the ln of the quantity of x squared plus y squared, that becomes the ln of r squared. So, to evaluate this limit, what are we going to do? Well, you could try to plug in. My first factor is approaching 0. My second factor, the ln of something getting closer to 0, that's approaching negative infinity. Now, in order to evaluate this, I'm going to rewrite this in a way that looks a little strange. What I'm going to do is I'm going to keep the ln of r squared in the numerator, but the r squared, the multiplication by r squared, that is the same as division by 1 over r squared. So multiplication by r squared is the same as division by 1 over r squared. Now, if you tried direct substitution, you would get negative infinity over positive infinity. So that L'Hopital's rule is applicable. So by L'Hopital's rule, what do we have? Well, we have the limit as r approaches 0 from the right. The derivative of the numerator. The derivative of the ln of r squared is 1 over r squared times 2r by the chain rule. In my denominator, the derivative of 1 over r squared, the derivative of r to the negative second power, is negative 2r to the negative third, or negative 2 over r cubed. So what does this give us? Well, if we simplify, if we do this algebra, in the numerator, I'm getting the limit as r approaches 0 from the right. I've got 2 over r. Now, dividing by that fraction is the same as multiplying by the reciprocal. So I'm multiplying by negative r cubed over 2. This gives us the limit as r approaches 0 from the right of just negative r squared. To evaluate that limit, I plug in and I get 0, my final answer for the question. Hopefully that's helpful and it makes sense. Have a good rest of your day.